Welcome and thank you for joining us today for this SPE Tech Talk with Halliburton. I'm your host for this broadcast, Victoria Jones. Lost circulation is the main contributor to non-productive time during well construction, otherwise known as NPT, and it's a costly challenge for operators to overcome. We're joined today by Halliburton to discuss the importance of understanding the loss challenge to tailor a treatment that helps operators cure severe to total losses. We'll also introduce you to a technologically advanced cement system designed to help cure losses and enable further drilling to help achieve zonal isolation. One great way to interact with today's broadcast is to let us know where you're watching from and to share your opinions on today's topic. If you have a question for today's expert, type it in the comment section for a chance our guests will answer it during our Q&A segment. So before we begin today's discussion, let's take a look at today's poll question. How often do you face lost circulation while drilling? A, 50% or more, B, less than 50%, C, rarely. Let us know your answers in the comment section and we'll take a look at the results later on in the show. Let's get started and introduce today's guest. Joining us today from Houston, Texas is Nasruddin Al-Bari, Global Product Champion supporting chemistry and applied science projects with Halliburton. Nasruddin has 14 years of experience with Halliburton cementing and has held a range of roles across various regions globally, from field engineering and technical advisor to business development. He holds from Texas A&M University in petroleum engineering. Hello, Nasruddin, and welcome to this SPE Tech Talk.
Hey, Victoria. Thanks for having me. Excited to be here.
Yeah, absolutely. So let's start off by asking, what are the challenges lost circulation presents during well construction and the consequences when losses are not mitigated?
This is a great question to kick us off here because it is always a good idea to quantify the problem, before talking about a solution. So lost circulation can lead to a range of consequences, varying in degree of financial impact. On one extreme, lost circulation can lead to losing the well completely and having to abandon the well. Now, fortunately, this is the least probable scenario. But on the other hand, there are other costly outcomes when talking about lost circulation. Those include, for example, losing significant volume of drilling fluid to the formation. Now, this can be significantly costly, especially when we're dealing with very expensive oil-based muds, for example. Another outcome is losing well control due to the fact that we're going to be losing hydrostatic pressure. Now, which in itself, has a lot of serious consequences, including HSE challenges as well. Lost circulation can also lead to wellbore instability. This can result in hull collapse, and consequently, can result in either stuck pipe or annulus pack off. That's going to depend on the severity is going to depend whether we're drilling or running casing or cementing. All these consequences lead to the same conclusion, which is non-productive time. Whether that non-productive time is spent fighting losses, or working a stuck pipe, or fishing downhole tools, or sidetracking sometimes. In addition to that, while pumping LCM materials downhole, there is always a risk of plugging downhole tools with the LCM materials itself, which can be catastrophic, especially while pumping cement, for example. And if the casing is still full of cement and we plug off the downhole tool, that can be catastrophic. Now, speaking of cementing, when we look at the negative effects of lost circulation from a cementing standpoint, losses can lead to poor hull cleaning due to the lack of circulating the well fluids to the surface, which, poor hull cleaning, coupled with the hull instability issues that I mentioned earlier, can lead to increased annulus pressure while cementing, which can contribute to either further losses or if we can't frac the formation, it can lead to a premature termination of the cement job. Now, this results in having to drill out cement inside the casing, which is, again, increases NPT. and the cost of the rig time. There's always a risk of not achieving desired top of cement as well, or not achieving the required zonal isolation from the cement job. This can result in challenges like sustained casing pressure, for example, or maybe even losing some of the production due to inadequate zonal isolation. Again, all these challenges mentioned here, the final result of those are increasing the total cost of the well.
That makes a lot of sense. So what is the Halliburton approach to solving severe to total loss circulation challenges? I know we touched on those challenges a little bit more, but love to hear your perspective on that.
Yeah, sure. So at Halliburton, we have over 100 years of experience in well constructions, and a big part of that, experience in treating severe to total losses. Obviously, local experience is very important, and a great source of lessons learned and information when trying to design a treatment for losses. But previous experience does not always imply future success, especially when we're drilling in new areas or new reservoirs where we don't even have previous successful experience. And that is why at Halliburton we focus on understanding the loss challenge before we tailor or recommend any treatments. So to understand the challenge, it is important to understand things like loss rate and the depth of the loss zone. The depth is very important and critical when it comes to, especially when it comes to using a dedicated loss circulation pill. It is also very important to understand the mechanism of the losses, and by that I mean are the losses a result of high formation permeability, which are typically associated with sandstones and unconsolidated formations. In cases like that, a continuous particulate treatment type of solution could be a good option. Those particulates will help by creating a film around the formation face, or if you want a filter cake across the formation face, which helps eventually reduce the permeability of the formation and reduce the losses that way. But if the losses are due to naturally fractured formations, for example, typically encountered in carbonate and dolomite type of formations, the treatment can vary depending on the fracture size. It can vary from just using particulates if they are very small fractures, to particulates, plus composite LCM packages, that include bridging materials like flakes and fibers, with different shapes and sizes that will have a better chance in plugging bigger fractures than particulates would have a chance to do that. But if we're dealing with even larger fracture geology, geologies like vagular geologies and cavernous type of geology, common LCM usually don't have a very good success rate in these type of geologies. They're not very effective. So what we need here is a chemically reactive solution, to create a chemical reaction, a viscosity type of reaction to help plug those large voids downhole.
Well, thank you so much for painting the picture for us, and thanks for the great information on today's topic. But before we continue, I do want to pause and just remind our audience to get involved in the discussion today. So type in any comment or question that you have on today's topic now for a chance our guests will answer it during our upcoming Q&A segment. So moving in here, what solutions does Halliburton provide to cure severe to total losses?
Well, thanks for that question, Victoria. So at Halliburton, we have a range of solutions for each loss scenario that I mentioned before, right? Depending on the mechanism of the losses. But for the interest of time, what we're going to focus today is on our approach to treating severe to total losses when typical LCM materials are not very effective. And again, the challenge calls for a chemically reactive solution. So that's what I'm going to cover today. Those types of losses are typically associated with highly fractured, vagular, and cavernous type of formations. and usually some of the most challenging and the most financially impactful loss circulation events. So several years ago, Halliburton developed a new system, our Sentinel-SEM cement system, which is a loss circulation solution that falls under the reactive treatment category. And it is ideal to treat severe total losses, like I said, in formations that are highly fractured with big fractures, right? So what we have done is we've already used and utilized this solution in hundreds of locations around the world with a very high success rate. It's been around for a few years already. It has been used to cure total losses or high losses of a rate of as high as 1,000 barrels an hour, dynamic loss. There are actually multiple SPE papers out there available that detail the success stories of utilizing this solution in different regions of the world, from the Middle East to the Asia Pacific to North America land, Latin America, and Africa as well. So we offer this solution, the Sentinel-SEM system, as a part of our loss circulation portfolio in our cementing PSL. But we also collaborate with our drilling fluids product service line to provide our mud engineers, to add the Sentinel-SEM system to our Baroid loss circulation decision tree. That way, we can allow our mud engineers to have a different option, right? A different option when their typical loss circulation situations are not the right fit for the application they have at hand. So we're also excited to announce that we have recently developed the next generation of our Sentinel-SEM system, which is Sentinel-SEM Pro, which will be commercialized here soon in Q1 of 2024, hopefully. So the new version will have all the outstanding benefits and features the legacy system had, but it's also going to provide additional several key improvements to the product.
Very good. Well, I actually want to touch on this a little bit more about Sentinel-SEM and Sentinel-SEM Pro Cement. You did kind of cover that, but I want to dive into it a little bit more. Can you talk about more so how they work to cure losses?
Absolutely. Sure. I'll be happy to do that. So Sentinel-SEM cement is a shear rate dependent thixotropic loss circulation solution. I know this is a mouthful, but I'll explain it here. So this means that the product gels rapidly when shear rate or pumping is stopped and the product is static. But when we return to, it's going to return to being a liquid when the shear rate or pumping is applied again. It can survive multiple cycles of hesitations and return to being a pumpable fluid after each cycle. Now, this property is very important because it helps the system penetrate deep into the fractures, which allows to address the cause of the loss circulation event deep into the formation, rather than just fixing the problem at the formation phase. So this loss circulation material is deployed by placing the work string above the loss zone, right above the loss zone, and then the treatment is pumped downhole. Once the treatment is in place, hesitation cycles, it's either left static or hesitation cycles are performed. During the hesitation cycles, the gel strength of the treatment increases drastically. And that helps stop the flow of the downhole fluids into the loss zone. So that's the way it treats losses. So I have some charts here to depict the thixotropic nature of the property, the nature of the system. So what you're looking at here is a thickening time graph for Sentinel-SEM Pro at the different densities and different temperatures. The green curve, if you can see here, is the consistency, which is an indication of the viscosity and the pumpability of the slurry. Those spikes you can see here in the green graph suggest or correspond to the static period in that test. So we shut down the test for 10 to 15 minutes, and the spike here is an indication of the thixotropic behavior of the slurry. So what you can see here is the slurry consistency more than triples, when the test is shut down, meaning, we remove the shear rate. Once we resume the test, again, apply shear rate again, the slurry consistency goes back down to a very low value, indicating that the slurry now is back to being a liquid. So after the gel strength development of the Sentinel-SEM system, the Sentinel-SEM system starts to gain compressive strength. Yeah, I'm done with the graph here. So after the gel strength development, the Sentinel-SEM system starts to gain early compressive strength, which helps support the open hole after the treatment had been drilled out. And that allows for quick return to drilling ahead, right? We've been able to achieve 100 psi compressive strength in a few hours, so we can go quickly back to drilling. So, more features of Sentinel-SEM Pro is that it is a lightweight slurry. So we targeted 10 to 12 ppg density range, right? The light density here was, targeted to help reduce the equivalent circulating density the formation is going to be exposed to, because that will help minimize the chance of breaking down the formation and increasing even the loss scenario here. Another great feature of Sentinel-SEM cement is that the product can be pumped down the BHA without the risk of damaging the internal components of the BHA, because of the fact that the solution has a very low abrasion effect. Now, this feature eliminates the need for a BHA trip. You don't have to trip out of the hole and trip back in with an open-ended pipe to place the treatment. You can just, pump it down the BHA. So eliminating that trip, obviously, again, eliminates more MPT and rig associated, cost associated to rig time. The last feature I want to cover here for Sentinel-SEM is the system is acid soluble. So it can be placed across, sensitive reservoir zones without any concerns related to, reservoir damage, because after you drill out the treatment, you can just clean it up with acid.
All right, makes a lot of sense. Thanks so much for providing that chart too, for our audience to get a better picture of what we were looking at. So we've covered the features. What are the key improvements Sentinel-SEM Pro Cement provides compared to some of the legacy systems?
Sure. Yeah. I'll go over those here in a minute. So when we developed the Sentinel-SEM Pro, we focused on two key improvements, ease of deployment and making the system more versatile when it comes to tolerance to hard mixing water. That's, mixing water with high mineral content. And also we wanted to make it more tolerant to the different types of cements that we use around the world, the different classes of cement, because we're going to end up mixing the treatment with Portland cement, and you have different types of classes of cement around the world. So we want to make sure that the system can be versatile to be tolerant to that. So when it comes to ease of deployment, the new version is a single sack. So it's a single sack solution, which helps with proactive storage, for example, on offshore or remote land locations. This is very critical, because when losses are encountered, it is imperative that we are able to deploy a treatment as soon as possible to minimize, again, the cost associated with rig time, waiting for a treatment to be delivered to location. If you have that product already proactively stored on location, that definitely ensures that. So more ease of the deployment. Sentinel-SEM Pro system can be mixed either on the fly or in a batch mixer, which is, not only reduces the complexity of the cement job, but also reduces the total cost of the cement job, because by eliminating the need for an extra piece of equipment, meaning here the batch mixer. Also, being able to mix the slurry on the fly helps with when we are dealing with large volume treatments. If we need a couple of 100 barrels treatment, if you can mix it on the fly, that's very critical, because obviously batch mixers, they have very limited volume capacity. So that is the improvement, the main improvements when it comes to ease of deployment. From a technical standpoint, however, the new version is tolerant to hard mixing water. We've been able to achieve the required gel strength development, even with field waters with very high mineral content. The product was also designed for tolerance to KCl water and also to be tolerant to sea mixing water, which is very critical for our offshore operations. Well, in addition to that, Syntel Pro is very compatible with and easy to design, is the main important thing here, with a wide range of cement classes around the world, right? In the verification stage of the product, we've tested the product globally in over 20 of our local cementing labs, using their local waters, using their local cements, and we've been able to achieve the required properties in all cases with varying degree of concentrations of the product. So why is this important? Because the ease of design with different classes of cement and local waters helps minimize the time it takes to optimize a design in the lab and be ready to deploy it on location. And again, the target here is reducing MPT. So we developed Syntel Pro cement with a main goal in mind, right? To provide more value to our customers. We do that by providing an effective loss circulation treatment that addresses severe to total losses, a solution that can be proactively stored on location, easy to design, easy to deploy, which again help achieve the main goal, that minimizing the MPT and quickly return to drilling ahead.
Great. Thank you so much for that information. So yeah, easy to design, easy to deploy, less time, and then of course, providing more value to your customers. So really good stuff. I want to say thanks again so much for the information on today's topic. But before we continue, let's revisit our results of the poll question that we had asked earlier in our episode. So we asked the audience, how often do you face lost circulation while drilling? A, 50% or more, B, less than 50%, or C, rarely. And it looks like majority of our audience, actually 100% of them said A for 50% or more. So were you expecting these results, or were you expecting something else?
No, absolutely. I mean, when we talk about generally lost circulation, yeah, I mean, over 50% is a question that's in line with what we have been seeing in the field.
All right. Well, I think now is a really good time to move into our audience Q&A segment. We're getting a lot of questions in, so definitely keep asking them, audience. We have time to get to them. So I want to take this first question here from Rubinger on Energy Stream, and they ask, can the Halliburton Sentinel cement be pumped through the drilling BHA?
Yes, I've gone through that, and it can be pumped down the BHA, and again, because the testing shows that the product has a low abrasion effect. So, the concern of, damaging the internal components of the BHA is addressed with that testing. And the testing results show that, we're not concerned about that. And again, that's a very good question because, not having to trip out of a hole with a BHA and then trip back in with an open-ended, saves a lot of time saves a lot of MPT, obviously.
Great. It looks like we have another question here from Paul J, and he's interested in the documentation of this new product on the Halliburton website, and can we get access to it?
Yes. We're going to be launching the product, commercially in hopefully January. So all this information is going to be available on our webpage for anybody interested in looking into the information. Yeah.
All right. Now it looks like we have another question from Paul saying, usually when drilling with known losses, pump in BHA, but what about nozzles, which is a very small restriction? So sorry about that.
So, I mean, the smaller restrictions are not a problem. The solution actually have, low particulates percentage. And, if you don't add LCM to it, which is you don't plan to add typical LCM materials that, the bridging materials, the ones that have large particulates, we don't usually add it to the system. The system itself works in a chemical reaction, produces viscosity, So we don't really need bridging materials. So in that regard, the answer to the question is yes. I mean, even the nozzles, if the nozzles are small, it is actually a great choice to go with central SEM because it has very low percentage of particulates in the system.
Excellent. Looks like we have another question here from Thomas Smith. What makes it acid soluble?
It makes it acid soluble because we add calcium carbonate to it. So calcium carbonate, we can make it as a main component of the product. And in that case, calcium carbonate can be dissolved with the HCl, 15%, for example, HCl acid.
Okay. I have a question here. So can Sentinel SEM Pro cement be deployed with casing in the hole? With the casing in the hole?
Well, this is outside of the scope of the general scope of the product, right? So this solution is meant to be deployed in open hole situations because for the treatment to perform, as I explained, it needs to be hesitated, or it needs to be shut down. It needs to go through a static period, right? And the hesitation, there's always a risk of either the Sentinel SEM itself, or if you are planning to use it as a lead, which is again outside of the scope of the product, it's either the Sentinel SEM Pro or the cement behind it will not survive multiple shutdowns, and become unpumpable, and that's a risk of terminating the job before planned, right? Specific scenarios, however, can be evaluated with detailed risk assessment and clear job objectives identified between the customers and Halliburton Cementing for the scope to be extended for the product to be pumped while the casing is open hole. But the short answer is the product is to be pumped while drilling in open hole scenarios.
Excellent. Well, it looks like we have time for just one more question. So I'd like to wrap with this, and then maybe any final thoughts that you have as well, anything that we haven't covered today. But how much Sentinel SEM Pro cement volume do we need to pump to cure severe losses?
Well, generally, this can be decided based on, it's going to depend, right? That's the general question, the general answer here. It will mainly depend on the loss rate. How much are you losing, barrels per hour, and then the hole size, because hole size is going to come with contamination as well. So the bigger the hole size, the higher the loss rate, the larger treatment you're going to be needing, right? But based on previous volumes or previous success stories we have, successful treatments start from 50 barrels. We've been seeing success from 50 barrels to go up to a few hundred barrels of treatment. What is really important, in addition to treatment volume, is following the recommended practices when executing the job, right? So most importantly, minimize fluid flow downhole by shutting down the backside of the casing, for example, so that we give the treatment enough static time to build that gel stream. So volume, it depends on loss rate and the size of the hole, basically.
Excellent. Well, a lot of great information here today. Really appreciate you joining us for today's SPE Tech Talk on innovative solutions to cure severe to total losses. So Nazar will get in contact with you if they want to learn more about Halliburton, about this product, everything that we're talking about today, and get in touch with you.
Yeah, I'm available on LinkedIn, and my LinkedIn information is here. But also, you can communicate with me on my Halliburton email. It is my first name dot my last name at Halliburton.com. So nasraldin.alarbi@Halliburton.com, and I'll be more than happy to help.
Excellent. Well, thank you so much again, and special thanks to Halliburton. You can watch a replay of this episode on the SPE Energy stream, the industry's digital pulse. Visit streaming.spe.org. I'm your host, Victoria Jones, and next time right here on SPE Tech Talk.
Thank you very much.
In a rapidly evolving energy industry, you need to stay ahead of the curve with relevant content available when and where it's convenient for you. You need the upgraded SPE Energy Stream. the global platform for high-quality content with the energy industry. Fuel your energy career with Energy Stream's sleek new look and easy access to top-quality technical solutions, insights and innovations, trending topics, thought leadership, market outlooks, and education. From original programs to exclusive SPE event highlights, this exciting, easy-to-navigate platform features insightful content delivered live and on demand. Explore insights from industry thought leaders. Then save the videos that interest you and watch them at your convenience. Be at the forefront of energy knowledge and explore the newly updated SPE Energy Stream now.